Hey folks, welcome back to another video. Today we're looking at question 341, flatten nested list iterator. The way we'll be approaching this problem is by actually flattening the list right here at the beginning so that we don't have to do any kind of computations when the next method or the has next method is called. So let's jump right in. The first thing that we need to do is actually keep a list of all of the integers after we flatten the list. So let's do that, just that. We initialize the list. The next thing we do is that we want to keep a track of what position we are at to keep a track of what to send when the next method is being called. So once we have the next iterator method and we're given the nested integer list, we need to call, let's call a flatten method on this particular nested list. And this is the method that we will be creating. So it will be private. It's not really returning anything, so it'll be void, and then it will be called flatten. And let's copy this. Right. So what we need next is we need a for loop. We say for nested integer I in the nested list, we iterate through every single nested integer. The first thing we need to do is that if I dot is integer, what you need to do is you just need to add that to the list. List.add I dot get integer. If it is not a list, so if it is not an integer, we know it is a list, so you just have to call flatten again on that particular list. So it would be I.get list. So you're basically calling this recursively anytime you get a list, and because we're calling it in order, everything will be saved in the order that we actually want. So the order right here is preserved. So this is the meat of the entire solution. So once you understand this, everything else becomes really easy. So what is next? So you just need to return list.get integer at the particular position and just increment it right after. That's it. That's the only thing that you need to do when the next method is called. And has next, you just have to return the position that we are at currently. Is it less than the size of the list? If it is, it means it has something after. If not, it's false. So this is the entire solution. Let's quickly compile this and see if it's okay. The first test case looks okay. Everything else looks okay as well. Awesome. So let's talk about the space and the time complexity. For the individual methods, next and has next, the time complexity is of n since, it's of 1 constant time since both of these operations get from a particular position and looking for the size of the list, it's in constant time. So for the individual methods itself, it's of 1. However, the space complexity for the entire solution itself would be of n since we're using a list to store the flattened integers. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Please don't forget to subscribe. I would really appreciate that, and see you all in the next video. Peace.